Welcome back, everyone, to this topic of deformation and springs. This is part three to this topic. And for this part three, we're going to look at extension load graphs. So last time we looked at springs and how they follow Hooke's law. That means if you double the force exerted on the spring, it will extend double. If you triple the force on the spring will extend triple the amount. So that's Hooke's law. We also looked at calculations involving Hooke's law, and you use this formula here, F is equal to K times E, and you did some calculations with it. Today, we're going to look at the extension load graphs and how to read and how to get information from the extension load graphs. All elastic objects follow Hooke's law, and because of that, if you do an experiment and then you plot a graph for that object will always have a straight line graph like this. Okay, so you plot E, that is the extension. Okay, berapa tambahan panjang springnya, and F, that is the force, how strong the spring is being pulled. You have an extension force graph. So from this graph, we can figure out a lot of things about the elastic object. So let's do example 1. So this graph shows how the extension of a spring varies with the load. A, what is the extension of the spring when it is attached with a 40 Newton load? So berapa extensionnya kalau sekiranya loadnya ataupun force-nya 40 Newton. So how to read this graph? Force-nya 40 Newton, so this is the force. And then all we have to do is, from this force, you go up until you touch the graph. And then you go to the y-axis. And whatever number you land on, that is the extension. So for A, the answer is 4 cm. In other words, when the force is 40 Newton, if you pull the spring with a force of 40 Newton, the spring will extend by 4 cm. Let's do B. At which load gives an extension of 2 cm. So this is the opposite now. So if we have extension of 2 cm, how much force is needed to make that extension? So berapa force is needed? So what you do is you go there up until you reach the line, and then you go down, and wherever you land on, that is the force. So an extension of 2 cm, you will need a force of 20 Newton. So that's the answer if you want to extend it by 2 cm. Example 2. Here we have a different graph. This extension load graph is for a spring. The original length of the spring was 10 centimeters. So this is very important. At which load would give a spring length of 15 centimeters? So the spring original length is 10 centimeters, and we want to know how much load we need to give to the spring, berapa force-nya, in order to make it 15 centimeters. So this is the spring here, and it has an original length of 10 centimeters. We want to know what is the load in order to make the spring 15 centimeters. Okay. In order to answer this, we need to know berapa extensionnya dulu. Okay. How much the spring has extended in this case. So original is 10 centimeters. It becomes 15 cm. So the extension is 5 cm. So you need an extension of 5 cm in order for the spring to become 15 centimeters long. So then you can look at the graph. So find where is 5 cm. So 5 cm is somewhere here. Okay. So when you have an extension of 5 cm, you need to find where the force is, and the force is here. Okay, so that's 20, that's 30, this is in the middle. So that means this is 25 Newton. So the answer is 25 Newton. Okay, so in other words, a force of 25 Newton will give an extension of 5 cm. And when the spring extends by 5 cm, the spring becomes 15 centimeters. Okay. Example 3. The diagrams show a spring having a length of 9 centimeters when loaded with a 100-gram mass. And the extension mass graph for the spring, so that is the graph on the left. What is the length of the spring after the 100-gram mass have been removed? So we want to find the original length. So if you remove the load, the spring will return to its original length. And what is that length? Okay, so first, we need to find again extension. So E, extension. When the spring is given a mass of 100 gram, we can find out the extension from the graph. So let's trace this graph up there and then there. That will give us 2 centimeters. Okay, so in other words, when we are giving 100 gram of mass to the spring extends by 2 centimeters. But you see the length of the spring is 9 centimeters. So the original length must be 9 centimeters, the current length minus the extension, and that will be 7 centimeters. So that's the original length. Okay, so in other words, awal-awal dia punya panjangnya 7 centimeters, Tani bagi 100 gram, and then spring to extend by 2 cm to become 9. What we're doing in this case is we're just working in reverse, okay, thinking about it in reverse in order to find its original length. Example 4. A spring balance is calibrated to give readings in newtons. The graph shows how the extension of the spring varies with the load. So basically that's just saying this is what the graph is. A, what is the original length of the spring? So you see in this case, you have to be very careful because this graph is a different graph. On the y-axis, it's length. Before, it was extension. Okay, now it's length. X-axis is still load. There's no change there. A, what is the original length of the spring? We want to find the original length of the spring. So the original length is when the spring doesn't have any mass attached to it, when the spring is carrying 0 load. So that is when the spring punya load is 0. And when the spring punya load is 0, the length is 10 centimeters. So this is the original length. Okay, artinya kalau ia nak tarik apa-apa, kosong force-nya, length-nya from the graph is telling us the length is 10 centimeters. Okay, length bukan extension. So don't confuse about that. So at which load gives an extension of 20 centimeters? This is a length and load graph. So we need to find what's the length when the spring has extended by 20 centimeters. Original length-nya is 10. And kalau ia kena extend by 20, what's the length now? So the length now is 30 centimeters. Now from the graph, we want to find the load from looking at the length. Length is 30 centimeters. And so if you do that and then you go down, you will find that the load is 100 Newton. So the load is 100 Newton. That's the answer. All right, so that's the end of the lesson. We've just looked at some example questions that you normally encounter when you do your O-level exam papers. So we looked at the extension load graph and we learned how to get the numbers, how to get the extension, the load, just by looking from the load graph. The other thing that you need to be careful of is you need to look at the axis. So it should be extension load graph, but as you can see from example 4, sometimes it's a bit different. Sometimes it's length and load graph. So when that happens, you have to be very careful.